Welcome back to yet another revision series from my channel, Interactive Education. And today we will be revising the chapter. Uh, we'll be revising light, and light is something where people, often some people have confusion. Although I feel physics is very simple this year, but some people do have some problems in physics, so we're going to address those problems now, right? So I hope everyone is going over a great revision. I hope everyone's revision is going perfectly. So we're going to start off with this revision session where I'm going to discuss some doubts, and I'm also going to discuss some important concepts in this chapter and basically in physics as a whole, both light, reflection and refraction, as well as human eye and the colorful world. So let's first start off with light. Now, first of all, the topics on which you need to focus. Okay. First of all, I'm going to discuss those and then some important concepts. The first chapter, light, reflection, and refraction, the most important part in this chapter is refraction. Okay, you need to be clear with refraction and especially refraction through spherical lenses. Those are very important. Refraction in general as well as refraction through spherical lenses. Very important topics. You need to be clear with them, right? So refraction plus lenses, which includes calculations, that is numericals, which includes ray diagrams, and also includes power of a lens. Okay, power of a lens calculation is important. Power is equal to 1 by focal length in meters, or if it is given in centimeters, then it is 100 by focal length in centimeters. Please remember this. Power is very important. Power of a concave lens is always a negative, whereas power of a convex lens is always positive. Please remember this. Okay, do not forget it. It is extremely crucial. Okay. The second thing in this chapter which is important is reflection, especially reflection through spherical mirrors. Okay, reflection through spherical mirrors, very crucial, especially spherical mirrors. And this involves again ray diagrams, sign conventions, and numericals. Very important. Please be clear with it. Reflection and refraction, two important parts in this chapter. Refraction, of which lenses is very important, and reflection through spherical mirrors. Please, one thing is to be clear in this chapter. You need to be clear with the difference between the lens formula and the mirror formula. Now here, please be clear with it. People get confused because of the signs. Please don't get confused because of the signs. I'll list the formula down for you. When you have a mirror, what you're supposed to follow, and when you have a lens, what you're supposed to follow, there are two different things. Although the formulas are very similar, you need to be clear with the sign. In mirror, the first formula is 1 by V plus 1 by U is equal to 1 by F. Please, this is the formula. Where V is the object distance, V is the image distance, U is the object distance, and F is the focal length. For lens, it is just exactly similar except for one sign change. It is 1 by V minus 1 by U is equal to 1 by F. That's it. That's the only difference. So because of this plus and minus, people get confused. Please don't get confused. Mirror is plus, lens is minus. Okay? Mirror is plus, lens is minus. The second formula, which has very slight variation, is the magnification formula. Now you know that the magnification is equal to height of image by height of object. Now this is written in terms of object and image distance as minus V by U. It is written as minus V by U. But in the lens, the sign changes. Magnification is equal to height of image by height of object, which is equal to V by U and not minus V by U. Okay, again easy but confusing. Please revise this carefully. Revise the sign convention. In this chapter, the trick is with sign convention. if you are clear with sign convention, if you are perfect with sign convention, if you're perfect with these formulae, no one can beat you in this chapter. I'm telling you, it is the easiest chapter. Okay, so light, reflection, refraction, please be clear with the formulae, the sign convention, the Cartesian sign convention, refraction, reflection, lenses, spherical mirrors and ray diagrams. Very, very important. That's it. You're clear with this chapter, right? So that's the important part with light, reflection and refraction. The next chapter is human eye in the colorful world. Now this too is an important chapter with regards to weightage. Okay, human eye and the colorful world. Now in human eye and the colorful world, what chapters are important, what portions are important? Let's just go through these first. Now in this part, the first thing which is important is working of human eye. Now working of human eye includes everything, that is, it includes your parts of the eye, it includes near point of the eye, it includes far point of the eye, it includes range of vision. Everything comes under working of human eye. Please, parts and how it actually works, how the image is formed, how the image is seen, and also range of vision, that is near point, far point, everything comes under this. Please be clear with it. The second part is defects of human eye. Now defects of human eye, predominantly there are three in your course, but there is a slight mention of one more in the textbook if you see carefully. There are three main ones: myopia, that is nearsightedness, then hypermetropia, that is long-sightedness, and presbyopia, which is a combination of myopia and hypermetropia caused due to old age. So presbyopia, myopia and hypermetropia, these are the three major ones. Please be clear with their causes, their correction and what they basically mean. There is one more defect which is just mentioned in 2 or 3 lines, and that is cataract. Okay, cataract. Now what is cataract? Cataract is basically basically a defect of the human eye where the lens turns milky. Now in cataract, the eye lens turns milky. And because of this milkiness of the eye lens, just one basic thing happens. The vision becomes distorted. There is either partial loss of vision or complete loss of vision. Partial or complete loss of vision. And how can it be corrected? It can be corrected through surgery. Right. That's it. That's all. Clear, finished, colors. This is how you have to study the defects of human eye. 4 major defects, out of which 3 are very, very important: myopia, hypermetropia and presbyopia. And cataract is slightly just mentioned there in your textbook, so just go through it once. Okay, so cataract, hypermetropia, myopia, presbyopia, very, very important. Please go over these defects, their correction and everything, as well as the ray diagrams, okay, which are reflected and which are seen in your textbook with regards to their correction. The third part which is important in this chapter is dispersion of light. Extremely crucial, especially refraction through glass prism, dispersion through glass prism, and the two observations of Newton. The first observation was that he took one glass prism and he took another glass prism and he passed a spectrum through it. What did he see? The spectrum recombined together and he saw a ray of light, a ray of white light coming out of the inverted glass prism. So again, this is the recombination of spectrum, and second is that monochromatic beam of light cannot undergo any further dispersion. So that is also an important observation, that he took he took some beams and he made sure that one light only passes through. Okay, and that one light was passed through another glass prism, but it did not undergo any dispersion, and it was just seen with that same monochromatic color on the other side of the glass prism. Very direct question. This is important. First is your recombination of spectrum. Second is monochromatic beam of light does not undergo any further dispersion. So in dispersion of light, this is important. Also the basic diagram of dispersion. Diagram of dispersion is extremely crucial. Extremely crucial. If you don't learn this, there will be a problem, because I am expecting this question to come. The diagram for dispersion of light. Please, dispersion of light through glass prism. Revise it carefully. Draw the diagram. Practice the diagram. Okay, so dispersion of light. Another important part of this chapter is atmospheric refraction, okay, on the basis of which there are many phenomena. You should know the explanation of those phenomena, such as twinkling of stars, why planets don't twinkle, and why, because of the creation of apparent positions, there is early sunrise and delayed sunset. So atmospheric refraction, again, very important. Please go through it properly. After that comes atmospheric scattering. Okay, again, on the basis of this, there are many phenomena. Okay, atmospheric scattering of light. Okay, one phenomena is your Tyndall effect. Tyndall effect is important because the gas particles present in the atmosphere, they scatter the light just like colloid particles, and they scatter light in various directions. This is called Tyndall effect. Then you can also talk about color of the sky, color of the sun, again part of atmospheric scattering of light. After that comes your rainbow formation is important in dispersion of light. Please be careful, rainbow formation is included. Rainbow formation is very important in this. Please go over it carefully. So dispersion of light, atmospheric refraction, atmospheric scattering, and the applications of all these three should be clear. Okay, and rainbow formation is very important. You know, the diagram also comes that how rain droplet acts as a prism, and how that prism then refracts light, then disperses it disperses light, then it totally internally reflects light from the back of the raindrop, and then it undergoes refraction. So this is your dispersion of light. This is rainbow formation. Very important and crucial. Please go over it. Then atmospheric refraction and atmospheric scattering. So these are the 5 major topics in this chapter. Okay, so with this I have concluded the important parts in physics portion, what all you need to revise, what all are important, and where you need to focus. If you still have any kind of doubt, please post it in the chat box. Actually, I'm not too well today. I'm having a headache. But if you have any kind of doubt, you may ask very clearly. Okay, please don't hesitate in asking any kind of doubt. I'm always ready for any kind of doubts. Right? Now, Kshitij, who's one of my subscribers, had asked me to explain refraction of light. So I'll just do that now. Now, refraction of light. Now, basically, refraction of light is a phenomenon of light like reflection. Now, reflection is a kind of phenomenon of light. So, refraction is also a kind of phenomenon of light. And refraction of light basically is the bending of light. Okay, it is the bending of light when it enters one optical medium, or not enters, let us write it like this, when it moves from one optical medium to another, so this phenomenon of the bending of a light ray when it moves from one optical medium to another is what we call refraction of light. And this is caused due to variation in optical density. When there is a variation in optical density, it results in the variation of speed. And when speed of light varies from one medium to another, the light ray bends and its path also changes. This is why refraction takes place. That is, the bending and the retracing of light path takes place. The trace of the path changes, right? This is what refraction of light is and how it is caused. Now, if you look into refraction through a glass slab, which is in your practical course, which is there in your textbook also, which is very important example, please be clear with this. So if you take refraction through a glass slab, if you take a glass slab, and from that glass slab, if you trace the path of light, so for example, this is air and this is glass. So basically a light ray enters, okay, a light ray enters Okay, enters the glass. Now you know glass is more dense than air. Glass is more dense than air. You can generally say that glass is more dense than air. So there is an angle of incidence. And what happens when light moves from a rarer medium, that is less dense medium, from a rarer medium to a denser medium, it moves towards the normal. So it is going to move toward the normal. And this is going to be your angle of refraction. So this is your angle of incidence, this is your angle of refraction. So basically it bended towards the normal. Now after that, you are entering again the interface, which is the link, which is the basic boundary between air and glass. So you are entering the interface now. So now what happens when it is moving from a denser medium to a rarer medium? It is going to move away from the normal. So this is going to be angle of emergence. It is going to move away from the normal, right? So this is going to be the path of a light ray. Okay. Now, it has been observed that the angle of incidence will always be equal to angle of emergence in a glass slab. The angle of incidence will always be equal to the angle of emergence. Okay. So, this is the path of light in a rectangular glass slab through refraction. Two times refraction will take place. First it's entering from air to glass, then from glass to air. From air to glass, it's moving from rarer to denser medium. It is going to move towards the normal. When it is moving from glass to air, it is moving from a rarer to a denser medium. It is going to move away from the normal. Right? So that is your refraction through a glass slab, rectangular glass slab. Now, basically there are some laws of refraction. Just like we have laws of reflection, we also have laws of refraction. So there are two laws of refraction, just like two laws of refraction, there are two laws of refraction. The first law is the incident ray, the reflected ray, and the normal. The incident ray, the reflected ray, and the normal lie on the same plane. Lie on the same plane. Pretty easy to understand. They are in the same plane. So if you are considering these three rays, they are going to be in the same plane area. They are not going to be away. They are not going to be different from each other. They are going to be on the same plane area. So they are on the same plane. Sorry, this is not reflected. Yeah, this is not reflected. This is refracted. Okay, refracted ray. So incident ray, refracted ray, and the normal lie on the same plane. The second law of refraction is slightly different, right? It is a different kind of law. The second law of refraction is that the sine of angle of incidence, the sine of, the ratio of, the ratio of sine of angle of incidence to the sine of angle of refraction, to the sine of angle of refraction is a constant value. Is a constant value for a given pair of media. For a given pair of media. So media means optical media where they are going to travel, the medium of travel. So again here we come to mathematics, trigonometry, our favorite chapter. So the sine of angle of incidence, sine I by sine R, this is going to be equal to constant value. It is going to be the constant value. So what does this basically mean? If we have a rectangular glass slab and light is entering, again it is going to move towards the normal and then it is going to move again. This is going to be the path. So again this is going to be angle I, this is going to be angle R, right? So basically this means that sine I by sine R is a constant value, and This is basically the second law of refraction. There are two laws of refraction. This is the second law of refraction. Clear? So these are the two laws of refraction. Very, very important. Please remember their statements. They are extremely, extremely important. Okay. Now we come to the concept of refractive index. Now refractive index. Now what is refractive index? Basically refractive index is a measure of bending. Measure of the amount of refraction that can take place. Okay. Now it is basically a measure of refraction. It basically measures refraction that can take place in a particular given medium, given optical medium. So that measure of refraction is called refractive index. There are two kinds of refractive indices, two kinds. One is absolute refractive index. Second is relative refractive index. Right? Absolute and relative. We are going to discuss each of them. Absolute refractive index is basically defined as the ratio between speed of light in air to speed of light in a given medium. Speed of light in air by speed of light in a given medium. And here C defines speed of light in air, and V defines speed of light in a given media. Speed of light in a given media or medium. Now this is denoted as mu. Mu is a Greek letter which denotes refractive index. Okay. So mu in a particular medium 1 is defined as the ratio between speed of light in vacuum to speed of light in a medium 1. So V1. So mu1 in your textbook it is n. It is fine, you can use n or mu because mu is a Greek letter which denotes refractive index. So C by V1 is equal to mu1, that is the ratio between the speed of light in vacuum to speed of light in a given media. Okay, in a given optical medium, right? That is absolute refractive index. Relative refractive index is defined as, the ratio between the refractive indices of two media. The ratio between the refractive indices of two media. So what does this basically mean? For example, we have two media. Suppose we have this is some medium 1 and this is some medium 2. This is medium 1, this is medium 2. Now from medium 1 to medium 2, light is entering. From medium 1 to medium 2, light is entering and it is undergoing some refraction, whatever. Okay. Something is happening. Now, here how do we calculate the relative refractive index? Relative refractive index is calculated like this. Suppose the absolute refractive index of medium 1 is mu1 and absolute refractive index of medium 2 is mu2. So the relative refractive index of medium 1 with respect to 2, is equal to mu of 1 by mu of 2. Mu of 1 by mu of 2. The refractive index of medium 1 with respect to medium 2 is equal to mu of 1 by mu of 2. Now if you write this in terms of absolute refractive index, you will get the speed relation also. Mu1 is equal to C by V1 and mu2 is equal to C by V2. That is speed of light in medium 1 and speed of light in medium 2. Your C and C get cancelled. You get V2 by V1. So it is seen that the refractive index of medium 1 with respect to 2 is equal to mu1 by mu2, which is equal to speed of light in medium 2 by speed of light in medium 1. That is the reciprocal of their speeds. Okay, clear? Any doubt? So that's your relative refractive index and your basic concept of refractive index. Okay, very, very important. Right, so I hope you are absolutely clear with refraction and refractive indices. Sometimes they'll give you the concept, they'll give you the refractive index of one medium and they'll give you the relative refractive index. Then you'll have to calculate the refractive index of the second medium. There you have to just use this formula. Okay, they may also ask you sine angles, they may ask you an angle, and they'll give you the relative refractive index, right? There you have to give so for example, I'll explain it properly. So we saw this, right? Sin I by sin r is equal to a constant value. This constant value is nothing but, so this is some mu2 and this is some mu1. This is nothing but mu2 by mu1. This constant value is nothing but the refractive index of medium 2 with respect to 1. So it is mu2 by mu1. That's it. So if you get a question, you may get a question like this, that you have been given the relative refractive index of two medium and you have been given the angle of incidence, which will be a proper trigonometric angle. You will be given the angle of incidence with which the light is entering medium 2 from medium 1. Then you have to calculate the angle of refraction. So you just use this concept. That is why here your trigonometry will again come in use. So go over your basic trigonometric angles also, they may ask. Okay, so that is your relative refractive index and the basic concept of refractive index and refraction. Right, I hope that's absolutely clear. If you still have any kind of doubt, please post it in the comment section below or somewhere and I will definitely get back to you. So I think there's no one here today because I think everyone is busy studying. So I think I'll be done with the revision session in physics. I went through the different important concepts in each chapter. I went through the formula in each chapter, how you're supposed to focus on certain things. And I also went over the concept of refraction where Kshitij had a doubt, right? So I hope Kshitij, your doubt is clear. And spherical lenses, please pay close attention on spherical lenses. I really don't have time to make the ray diagrams and make a video on the ray diagrams. I'm really sorry for that. But if you still have any kind of doubt, I will be more than happy to have another session on physics and then we can discuss those doubts there. So thank you very much for joining me. I hope you understood something. I hope you're clear with all the concepts. If you still have any kind of doubt in physics, in biology, chemistry, or any other subject, please post it in the comment section below. Thank you very much for joining me. Goodbye. Stay healthy, stay smart, and do keep studying. Bye-bye.